So thank you all again for joining us. We are now in Worldwide Climate and Justice Education Month. We have had activities around the world already in various locations of schools and other um, communities. Some of them have been in person, some of them have been classes. There have been some virtual events. I attended a virtual event on Monday in from British Columbia, Canada, in Western Canada, on pedagogies for teaching about climate change. And we're going to be hearing today about resources that you can use in your own teaching. I'm going to begin by sharing our introductory video, and that will, I know for some of you this is a reminder, but will give you just a sense of what we're all about here with Worldwide Climate and Justice Education Month.
Where are you emotionally on climate change? 1 is I never think about. 10 is paralyzing anxiety, can't sleep at night, don't want to have kids because their world will be to this topic.
The Worldwide Climate and Justice Education Week is about helping people move from climate despair and disengagement to a mindset of climate repair. This is the education that changes the future. So Climate Week is for everyone. It's for students, faculty, and staff from all subjects, like artists and psychologists, scientists and business majors, students of music, literature, economics, international affairs, healthcare and engineering, you name it.
Join tens of thousands of people around the world in growing climate education. You're not alone. People on your campus are really worried about climate change. If you step up, others will join you. At your school, you can make climate an event. This means solutions and justice events on your campus. Art, theater, panel discussions, films, faith meetings, music, games, fairs, and displays. Check out our website for examples from all over the world. Engage your whole school.
On top of your events, you can also help to make climate a class. This means encouraging climate-concerned teachers from all subjects, art, history, chemistry, psychology, all subjects, to spend at least half an hour talking about how climate change solutions and justice are relevant to their field of study, how artists, historians, chemists, and mathematicians are all thinking about climate change. We have step-by-step guides on our website to help you make this happen.
Last summer was the hottest in history. Massive fires, heat waves, floods everywhere. We have to stop it from getting hotter every year. You can help organize Climate and Justice Education Week at your school. The biggest threat to our future? Thinking that someone else will lead, that someone else will stop the climate crisis. Now, not next month, not next year. We all need to step up. Join us.
Okay, thank you. And
I have a one.
Oops, oh, sorry. Sorry, the videos go on and on. So that gives you an introduction of Worldwide Climate and Justice Education Month. We had this was the video from last year when we had a 1 week session, and I know many of you are already organizing events at your schools and classes, and we encourage you that if you've not yet registered your activities to, please do so. I'll put the link in the chat and you can get on our map. For teaching and learning about climate change, one of the key things is that, as the video said, that you can be really in any subject. It's not just about the science of climate change, but it is essential that you do understand the science of climate change. We don't tell you what to do in your classes and activities, but we have lots of help that we can provide, including a lot of educational resources, um, sample curricula, lesson plans, things like that. So that's going to be our topic today. And we're going to be learning about some of the great educational resources that are available. Our speaker today is Don Haas. Don is a fabulous educator in climate change and an organizer of climate education communities. I've worked with Don for quite a few years at this point. And Don is the director of teacher programs at the Paleontological Research Institution, which is based in New York and not New York City, but upstate New York. And Don can tell you about that. So I'm going to turn it over now to Don and Velma, his cat, who can both entertain you and educate you. So go ahead, Don.
And I'm not sure if anyone joined after I put the agenda in the chat, yeah. So I just put it in there again. And I need to share my screen, which I don't have the ability to do quite yet until you click a button.
Sorry. Yeah.
That's okay.
I'll say no.
Thank you. Thank you. So here's the agenda and just a quick look at that, description of what we're doing today. And I'm going to start off with a presentation called Using Props in Social Math to Communicate the Scale and Urgency of Climate Change. And that's a shortened version of something I'll do next Tuesday evening, Central or Eastern time in the US. It will be recorded. So I know that 7 p.m. Eastern time in the US is not not necessarily compatible with people on other continents. So yeah. And there's a video of
it'll be about 4 a.m, I think, in Islamabad. So, but if you register for the webinar and it's a different registration form and link,
it is, yes. And
it's in Don's handout there, then you will receive a copy of the recording.
Yep. So I'm going to start with that sort of shortened version of what I'm going to do next week, and then I'll talk about resources from the Climate Literacy and Energy Awareness Network, which David and I have been part of for a long time. I was a founding member of that in 2008. And then I'll share some resources from the Center for Climate Change Education at the Paleontological Research Institution, and links to everything that I'm going to share is here in this document. So I'm going to start off with that using props. And let me actually make sure that I have refreshed the presentation, because there are some things that don't start right if I don't do that. And we will start it off. Okay. So we'll start off with the question of why do we have to get better at communicating the scale and urgency of climate change. And you can do the show of hands using the hand raise button in Zoom. And we've got a few questions. Do you know someone born in about 2010? That'd be a 10th grader in the US or so. So if you can raise your hands, that's great. If not, we'll just go ahead and I'll imagine you raising those hands.
Actually, I think we have people in this webinar who are born around that time.
Yes, I expect so. Do you know someone born in the 2020s? That means a baby to a 6-year-old. Um, uh, and I do. I have some great nieces and nephews. Is there a climate emergency? I think so. Um, and this is my grandmother, Nellie Brown Loomis, who was born in the 1890s and died in the 1990s. She lived to be 97. This is my daughter, Nellie Dugan Haas, who was born in 2004. And if Nellie lives to be the same age that her grandmother, or her great grandmother rather, was when she died, then she will see the year 2100. And most of us know and love someone who will be alive in the year 2100. Someone born today will turn 74 in 2100. And I raise this because, when we hear projections about the future, we hear about 2050 and 2100, and that feels so very far away for a lot of us. But it isn't. It isn't that far away at all. And I think that's important to recognize. So, another hand raising. Are you now or have you ever been scared about climate change? I certainly have. Um, and should we be honest in our climate education and communication efforts? I think so. Um, and Now I'm going to shift gears slightly before going on to talking about really the central science of the day is going to be talking about what happens to a gallon of gasoline. But it is much more deeply understood with an understanding of scale. And that's in part because in the US, we burn over 370 million gallons of gasoline on the average day, and there are only about 340 million Americans. So that means more than a gallon per person per day. But those big numbers are really hard for people to wrap their heads around. So if we were in person, I would have a sticky note on one corner of the front wall of the room with 0 written on it, and a sticky with a trillion written on the other corner of the front wall, and ask people to put a mark where you think 1 billion belongs between 0 and a trillion. And I see someone has done that, and you can go ahead and do that if it's easy for you to mark up the screen. And I do have an online polling thing, but I think that takes a little more time than I want to spend. But you can take a look at that and check that out and copy that for your own purposes. And again, all of the resources I'm talking about here are available in the document linked from the agenda. So I'll just ask you to use your mind's eye essentially to put where you think a billion goes between 0 and a trillion on that line, and I'll show you, spill the beans a little quicker than I normally would, what typical responses look like and what the correct answer is. The correct answer is that a billion is 1/1000th of a trillion. Each one of those named numbers that we hear regularly, 1,000, a million, a billion, and a trillion, is 1,000 times larger than the one that comes before it. And most people don't have a good understanding of that. And there's good reason for that. We don't have the evolutionary programming for it. I don't think that humans before about the time I was born in 1963, I don't think pretty much anyone really needed to understand the difference between 1,000, a million, a billion, and a trillion. And now I think everyone does, partly for understanding climate change issues, but also for understanding economic issues and population issues. And the list is really pretty long where understanding scale really matters. And we've got to work on doing that. And again, next week in the session that I expand on this, I'll spend more time on that, and I can answer questions about it too if they come up after this piece of the agenda. And I'm going to talk about social math, which is the idea of using familiar things to help people understand unfamiliar things, and particularly around numbers. So helping people understand large and small quantities by connecting to more familiar content. And I am going to talk mostly for the next 10 minutes or so about gasoline. And when I do this in person, I pass around a gallon jug that's 3/4 full of water. And it's 3/4 full of water because gasoline has a density about 3/4 that of water, and I don't want to pass around a jug of gasoline very much. And that's to give people a feel for what a gallon of gasoline is like. Um, and again, I said we burn over 370 million gallons in the US. That's very different in depending on your country context, and I recommend looking at the Energy Information Agency's website for comparisons of energy use in different countries. And that's a very interesting website where I learned while actually doing some work with climate educators in Kenya that our carbon emissions in the US, I believe, are, if I remember correctly, 42 times greater per capita than those in Kenya. So it's important to recognize those differences too. I am going to get to our gasoline piece. And I have here in my hand a block of pure carbon. It's graphite, the main ingredient in pencil lead. On the image there, there's a quarter, an American quarter to show scale. But it's you can see how big it is. And it's I want to know if you think it's a lot less than the amount of carbon in a gallon of gas, about the same amount of carbon as in a gallon of gas, and a lot more than the amount of carbon in a gallon of gas. And apologies for not going metric here. A gallon is about 4 liters. So you can picture if we're talking about 4 liters instead of a gallon, that's about the same. We'll do the show of hands thing, and I'll go slower this time so we have time to switch between the 3 choices. If you think it's a lot less than the amount of carbon in a gallon of gas, go ahead and raise your hand, and I'll pause for a minute to let people do that. Not seeing any of those. If you think it's about the same as the amount of carbon in a gallon of gas, go ahead and raise your hand, and I'll again pause, hopefully long enough. And if you think it's a lot more, I don't think I've seen any hands go up yet. So there goes one. So a couple think it's a lot more. And I'm not going to spill the beans just yet. We're going to step through some more stuff before we get to the answer. And I will ask the question again in a little bit. And in order to figure out where gasoline goes when we burn it, which is one of the titles for a version of this talk, is where does gasoline go? And we need to know about what gasoline is, and it's a complex mixture of hydrocarbons. It's mostly C8H18, which is octane. And what do you get when you burn octane? Well, you get carbon dioxide and water and energy, of course. And we're going to animate that combustion reaction. And I cheated a little bit by having things so the animation would work better. There are the oxygen diatoms, oxygen molecules. There's the octane molecule, and we give that stuff a spark, and things recombine. So now we have carbon dioxide and water. From that one octane molecule, we end up with 8 carbon dioxide molecules and 9 water molecules. And there are the carbon dioxide molecules, and there are the water molecules. And when we look at those 8 carbon dioxide molecules that we ended up with, it weighs a lot more than the octane molecule we started with. And that's not magic, it's chemistry. It's because we took the carbon out of the octane and combined it with the oxygen in the atmosphere. And we end up with we end up with 19 pounds of carbon dioxide from burning that 6-pound gallon of gasoline. And that generally makes people say, wow. And that is a big deal. And remember that we're doing that over 370 million times a day. And again, I will do this much more slowly on next Tuesday night. But the next piece of this is thinking about trying to wrap our heads around that 19 pounds of the invisible gas carbon dioxide. Um, so we're going to do that with gallon-sized balloons. So I'm going to blow up, if we were live, I would pass around balloons to everybody and ask them to hold them empty and think about what it weighs when it's empty, and then fill it up to about a gallon size. So I'll fill mine up to a gallon size. That's about right. So how many of these gallon-sized balloons would it take to hold 19 pounds of carbon dioxide? And when you're thinking about that, you've of course got to subtract the weight of the balloon itself. You're just thinking about the stuff inside it. So you've got to subtract that weight of the balloon and think about how many balloons this size would it take to hold 19 pounds of carbon dioxide. And if anybody wants to unmute and take a guess, go ahead and shout out an answer. I'll wait just a second or two for that. Anybody's brave enough, and that's okay if you're not. I will animate it again. So there's 100 balloons falling. That's not enough. 200's not enough. 300's not enough. 400 is not enough. 500 isn't enough. 600 isn't enough. 700 is not enough. 800 is not enough. 900 is not enough. 1,000 is not enough. It's about 1,100 balloons from 1 gallon of gas. So that's a lot. That should make you say, wow, again. And then the next question, and again, I know how fast I'm going, and I will slow it down next week. What do we do about all of that carbon dioxide? Remembering that in the US, we burn about 376 million gallons a day. That's over 7 billion pounds of carbon dioxide every day just from burning gasoline. For the US, that's about 25% of carbon emissions. And US emissions are about 13% of global emissions. So if we want to scale it up to our piece of, if we want to scale it up to look at all emissions, then we multiply by 4 to get us up to total US emissions and by 7 to get us up to total global emissions. And that should make you say, wow, that's a lot. And now we'll go back to our block of carbon and we'll see if perhaps any minds have changed. So we'll do the show of hands again. Is this a lot less than the amount of carbon in a gallon of gas? Is it about the same? And the popular answer before was a lot more. Is that still the popular answer? No answer is the popular answer this time. That's okay. So a gallon of gas is about 87% carbon by weight. That means there's 5.5 pounds of carbon in every gallon of gas. So that's about 2 kilos for 4 liters, or a half a kilo per liter. That's a lot. And here's what it looks like. Is this enough carbon for that gallon of gas? Not yet. There is this much carbon coming out of our tailpipes for every gallon of gasoline that we burn. I actually meant to order a 6 by 6 by 2 inch block, and I filled out the form wrong. And I think that was fortuitous because I think the prop is better as the smaller prop. But of course, when it comes out of your tailpipe, it doesn't look anything like that because it's in an invisible gas, carbon dioxide, but there is that much carbon coming out of your tailpipe for every gallon of gas. If we want to take that out of the air, of course, I should have said by now that the most important thing to do is stop burning so much stuff, stop putting so much carbon into the air. But the reality is we've been doing this since the dawn of the Industrial Revolution for more than 2 centuries, quite a bit more than 2 centuries. We've been putting a lot of carbon into the air, and we've got to figure out how to take some of that carbon back out. Technologically, the simplest way that I know how to do that is by planting stuff. And it just so happens that wood is about half carbon by weight. So if we're trying to take 5.5 pounds out of the air for every gallon of gas, that means we need to grow 11 pounds of wood. And that wood can't be allowed to rot or decay, or that would put the carbon back into the atmosphere. And it just so happens that what's probably the most common piece of lumber sold in the US, an 8-foot 2x4, weighs about 11 pounds. So this 2x4 has about the same amount of carbon as a gallon of gas. And that that means when you fill up your tank and you watch the gallons tick by, think 2x4, 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 or as a liter ticks by, you can think 2x2, I guess, or think of 2 foot long 2x4s, which again, apologies for not converting to metric here. So you can find the resources all shared there, and I use this presentation to a variety of audiences. And I deputize my audiences to all be climate educators and communicators. I think you're already there since you're in this particular session. One of the set of things that I like about this phenomenon are basically undeniability. You can't deny that a gallon of gas weighs about 6 pounds and has 5.5 pounds of carbon in it. At least you can't credibly do that. You can't credibly deny that we burn 376 million gallons of gas in the US on the average day. You can't deny that most Americans and most humans don't have an intuitive sense of scale. And you can't credibly deny that being scared or angry is motivating in the proper context. And I can talk more about that, the emotions in either the discussion or, again, next week in the session that I spend more time on this. Of course, some people will deny that stuff anyway. And when they do that, I think you hold that up for evaluation and help those people discredit their own arguments. And that's the end of this piece. So I'm going to pause and see if there are any questions or comments. Any questions or comments?
While you're thinking of that, thank you very much, Don. If you did not actually register for this week's session, but you're using a previous link, please put your email address in the chat, either directly to me or to everybody, so that I can make sure to email you the information that Don has provided and also the recording. And also, if you haven't signed up for the Climate Education Month, please do that as well. So, okay, keep on going, Don. Well, let's see, other questions or comments for Don?
Yes, please. I have a question.
Mm-hmm.
Please, Gilbert.
So, my question is based on what you said that Americans burn 376 million gallons of gasoline a day.
Mm-hmm. Yeah.
And then in the
Yes,
explanation, that
yeah.
means that is over 7 billion pounds
Yes.
of carbon dioxide produced
Yeah.
every day just from burning gasoline.
Yes.
So my question now, in the context of fighting this, I would like to understand how much influence do oil companies have over transportation policy? Thank you. That is my question.
That's a very good question. And the sort of snarky too short answer is too much. I'm very glad you asked that question. I changed my vocabulary around some of this, and it hasn't come up yet, thanks to reading my friend James D'Amico's book on teaching climate change in the social studies classroom. And the way he changed my vocabulary is he said instead of using anthropogenic climate change or human-caused climate change, we should say industry-led climate change. And I try and do that whenever the phrasing is appropriate for the discussion, as it is right now. I think the oil companies have a tremendous amount of culpability, and I would love to see them be held genuinely accountable for it. And I think we need to teach more about that. I think it's undeniable. Naomi Oresk's is co-author and I think co-producer of both a book and a movie called Merchants of Doubt that dig into that issue very nicely and thoughtfully. That book is, maybe 10 years old now, but I think the issues are unfortunately timeless. So very much worth talking about and digging into and figuring out how to hold the oil companies accountable, which unfortunately in the current political climate in the US, I don't think is going to happen here for at least a few years, but hopefully we will eventually get there. But that's a very important question and issue. And it's also worth noting that for a very long time, oil companies were major supporters of the National Science Teaching Association in the US. They are not anymore. But I think part of that support was intended to discourage teaching about climate change and other environmental harms that come from extracting oil. And I think they were unfortunately pretty successful at that. Other questions before moving on to the next piece?
Thank you very much.
Sir,
Yeah.
sir, I have a question that at your presentation, the topic is using props and social maths. Can you please explain the term social maths and
Yeah.
why it is useful for communicating this climate change specifically?
Yeah, so social math is the idea of using things that people are familiar with, like a piece of wood, and to understand quantitative issues. And I also sort of skipped over another piece of it. And let me switch to another presentation, which I'll add a link to in the document. Just a second here. Not that one. Not that one. Oh, I know it's already open. That's weird. No, it's not. Okay, there we go. So happen to be on the right page even. So let's go to presentation mode here. One thing that all of us are familiar with are seconds and minutes and hours and days and things like that. So to help us wrap our heads around the issues of scale, we can use time as an example. So 1,000 seconds is about 17 minutes. We're all familiar with that. 1,000,000 seconds is about 12 days. So when you multiply 17 minutes times 1,000, it gets you to about 12 days. When you multiply 12 days by 1,000 again to get to 1,000,000,000 seconds, that's about 32 years. So some of the people in this session are about 500 million seconds old. I am getting close to 2 billion seconds old. And when we multiply that billion seconds by 1,000 again to get to 1,000,000,000,000, that takes us to 32,000 years. And that takes us back before, if we go 32,000 years ago, that's before the dawn of agriculture and the dawn of civilization, as far as we know in any real substantial way. And Homo sapiens, our species, have been around for less than 10 trillion seconds. Which would be 320,000 years. The best current estimate of when Homo sapiens emerged as a species is about 300,000 years ago. So we as a species are less than 10 trillion seconds old. So that's one example. Another example is, if we go back to the timeline, or the number line rather, and we think about um, making that same scale of mistake, but for oops, that's not where I need to go. It's up in here, and I went to the right place even. Um, when we think about the scale of mistake here, if we did that with money and we said, I assume there's basic familiarity with the American dollar since it's all over the world in a lot of ways. If we scaled this down to going from 0 to 1,000 and asking people where one goes and think of dollars, it'd be like confusing $1 with $300 because the average answer is around a third of the way across the line. And of course, we won't make that mistake with scales of dollars, scales of money that we're familiar with. But I think it's a bigger deal when we confuse 1 billion with $300 billion dollars. And it's worth noting that the fighter jets that were lost to friendly fire in Kuwait, I think, is where that happened yesterday or the day before yesterday. That was about $300 million worth of equipment that went down in a very short amount of time. And I think confusion of 300 million and 1 million is a big deal. So another question, Gilbert.
Thank you. First of all, thank you very much for your meaningful explanations, Professor. So
Yeah.
please, my last question is that, as you also said, this 7 billion pounds of carbon dioxide sounds that they are a lot and a lot.
Mm-hmm.
So I wanted to understand, how does these 7 billion pounds of carbon dioxide per day translate into temperature rise? Thank you.
Well, again, I think you've got to think about scale and how to scale that up. And so that's 7 billion pounds from gasoline per day is going to be 7 billion times 365 per year, which I think I have in the presentation, but I don't remember the number off the top of my head, and my math skills aren't that speedy to do that in my mind. But we can compare it, and I think it would be a good student activity to sort of step through that and investigate it. I can't run those calculations off the top of my head, but if you look at how the atmosphere is changing and how atmospheric dynamics are changing as a result of the carbon dioxide that we're putting into the atmosphere, then we can figure out what fraction that the American use of gasoline contributes to that. But I can't do that math off the top of my head. But I do think that would be an interesting thing to dig into with students, and you'd have to spend some time to do that math.
Thank you very much.
Sure. Other questions on this piece? Switch over and switch gears a little bit. So I'm going to go into the Climate Literacy and Energy Awareness Network resources. And again, everything's linked from the agenda. So CLEAN was established in 2008. I was a founding member of it. And it has been funded by the federal government in the U.S. That funding stopped last year for obvious reasons, but the resources are still here, and that includes you can join the Clean Network, which is a listserv that shares resources and asks questions of the community and so forth. But I think the most important thing for you all is the Clean Collection, which I think has about 800 resources within it. Is there a topic that you'd like to see resources for related to climate change, Anybody want to shout something out that they're interested in seeing how to teach? What's not giving you enough time to do that?
Somebody want to pick a topic, maybe for Pakistan, maybe something about water availability would be a good one.
Okay, let's try that. And no matches.
Okay, well, maybe just put water.
Yeah, there will be lots of matches for that. 383 matches for that. So let's take a look at water everywhere. And this is an activity that begins with predicting and understanding the proportion of water in different places. And this sounds like it's got possibly some social math ideas in it as well. And you can click through to the resource here. So there is the resource, and looking at how much is in ice caps and oceans and groundwater and freshwater and so forth. So that's one resource. Is that it does, and you can see along the side here that it tells you what kinds of resource types are available that match the search, what grade level things are, what grade level resources are available, and you can click on any one of these and see that narrower set of resources, what climate literacy principles are addressed by the different resources, and resources for teaching across the curriculum, and so on. So this is a really rich resource. Let's do one more. If somebody wants to shout one out or put it in the chat, I can. Oh, there are things in the chat. Let's see what we got there. And not these things. I don't think. Okay. So let's do ocean acidification and see what comes up for that. And there are 39 matches for that. And again, you can see different ways of refining that further by grade level and so forth. One of the really nice things about the Clean collection is that every resource that's made it onto the website has been reviewed by both a scientist to make sure that it's scientifically accurate and a pedagogical specialist to make sure the teaching approach is appropriate for what it says. Some are go through additional reviews, I think, to be part of the reviewed collection, or maybe they all do, and maybe that button doesn't really mean very much. The newest edition, which will be unfortunately one of the last editions until the presidential administration changes in the U.S. because funding is over, is really, this one happens to be U.S. specific based on the National Climate Assessment, but you might find things that are translatable to other regions of the world, or if you want to compare where you are to somewhere within the U.S., you can use this to that end. The Clean Network was also the group that wrote the original climate literacy principles and were involved with the update in 2024. Those have been taken down from federal websites, but have been put at climateliteracy.earth, which has more resources for teaching about climate change, and it's where some of the Clean collection kind of activities will live on. Anything I should add about Clean, David, before moving on to PRI stuff?
No, I think that's good. In the interest of time, we should move on.
Yeah. The Paleontological Research Institution, my employer, was founded in 1932 to do what it sounds like a place like that would do. It was founded by a paleontologist at Cornell who was worried that Cornell would not take good care of his fossils when he retired. So he more or less said, I'm going to take my fossils and go home, and started his own institution that grew in reputation among paleontologists over the next several decades, and continues to have a very good reputation with paleontologists. And that means that when paleontologists died, or when departments of paleontology closed at universities, we would end up with their fossil collections. So now we have one of the largest fossil collections in North America, over 7 million specimens in our collection. um, and that led us in 2003 to open the Museum of the Earth. And even before that, we were doing some climate change and energy education. But it's not obvious from the name, the Paleontological Research Institution, that we do that work. And we've been doing a lot of it, especially over the last 10 years. But like I said, it's not obvious from the name Paleontological Research Institution that we do that. So we established the Center for Climate Change Education in 2024. And that just makes it easier to find these resources, we hope. We do teacher professional development. My colleagues and I wrote the Teacher-Friendly Guide to Climate Change. We have the Teach Climate Change page of the section of the website, which has resources. We'll take a quick look at a couple of these sections. The Teacher-Friendly Guide to Climate Change was published in 2017, and then we updated it and brought it online in 2022 and 2023. So these are the chapters that are online. There are a couple of chapters that are that haven't been updated yet, but the full PDF of the book is available here somewhere, so you can download the full book there. And one of the chapters that still needs to come online is climate change throughout Earth history, which is one of the ways that the book is different from some other resources. Another way that it's different is that we address some of the social science issues, the psychology around climate emotions, and the sociology around some of the things that make it more challenging, particularly in the US, I think, to teach about climate change than to teach about photosynthesis, for example. And the Teach Climate Change section of the website has activities that are sort of a lab guide for the teacher-friendly guide. And I should also say that when we brought the content online, I like to say, de-teacherified it, and made it into more of a textbook that could be used for a high school or an undergraduate course in climate change. And these resources go to support that. We also have quick answers, which have some frequently asked questions and some fact sheets on different aspects of climate change. And we have an extensive collection of videos in different video playlists. The In the Greenhouse is hosted by my colleague Alex Moore, who made these 10 to 15 minute long videos that typically are showing activities or investigations that you can do to explore some aspect of climate change. And I think there are now more than 20 of those. These are climate change shorts on solutions by my colleague Ingrid Zabel. And a member of our climate team who doesn't work for PRI, but rather works for Cornell, is Toby Alt, who's a professor of climate science at Cornell. And he teaches Cornell's large lecture class for non-science majors on climate change, and he's produced a series of videos that we're adding to, I think, later this spring, from the sort of snippets from his lectures, 15-minute long or so pieces of his lectures that he recorded in the Museum of the Earth, our museum, and then there are some other ones there, and what else do I want to say? We also have exhibits, and after during the pandemic, we decided every new exhibit would have an online version. So our Changing Climate exhibit you can find here, and step through the different aspects of the exhibit through those tabs. And I should probably stop and take questions and see what else you want to take a look at.
All right. Well, thank you, Don. So obviously there's a lot that you all can explore. We Don provided his agenda document, and maybe you should paste that back in the chat again because
Yep.
it has the links to all of these things. I've been sharing other links and information in the chat. So be sure that you've provided us with your email address so that we can follow up with a copy of that agenda with the information in the chat and the recording of this webinar. Um, so are there questions for Don at this point?
There's my email if you come up with things that you want to ask me later.
So I guess let me just ask the sort of one of the questions I asked the sort of same question yesterday, but I'll ask it again.
Sure. Sure.
So a lot of these, lot of our friends who are with us today are students who are learning about climate change in their own, hopefully in their own classes, but also in their own readings. So what you provided so much information, so much content. Where should they get started? You had some, for example, on your PRI website, you had some introductory videos and things. So where would you suggest that they get started?
Well, that's a great question. And if you're a reader, I would start with the Teacher-Friendly Guide to Climate Change.
Even if you're not a teacher.
Even if you're not a teacher, yeah, I think it's friendly to any audience really. And I'll note too that we've tried to come up with a different name, and that's really complicated. So if you have suggestions for that, we thought about the Everyone's Friendly Guide to Climate Change or something like that, but that's kind of clunky. But anyway, I do think that's a good place to start. And I'll note, we start off pretty simple. The first sentence of chapter 1 is weather tells you what clothes to wear, climate tells you what clothes to own, and sort of moves on in sophistication to some degree. But I think that understanding that burning stuff is the cause of modern climate change, and that has been led by industry since the dawn of the Industrial Revolution. And we've got to figure out how to not burn so much stuff are really important issues to understand. And again, I think the Teacher-Friendly Guide is a great place to start. If you're a teacher, Mark Windschittle's book is also very good, which I don't remember the exact name of, but it's about teaching climate change. And the videos, let me go to share again and go to the video page. Let's see. So videos, and go to Alex's YouTube playlist. Um, so, uh, understanding how carbon dioxide absorbs infrared energy is a good, very quick one, just a minute long. And then there's a longer related one here. But that's, I think that's the most important piece of science to understand is how carbon dioxide heats the atmosphere. And uh, so those are good ones to start with. Um, and the trees from thin air is thinking about how to mitigate climate change. So that's another good one. So and how to make a greenhouse in a beaker is another nice one that can be done in the classroom or in your kitchen. Stepping through how to demonstrate what's going on with the greenhouse effect. So those are some thoughts on that anyway.
Thanks, Don.
And I see
Gilbert?
Gilbert's got a hand up, yeah.
Okay, thank you very much. So my question is I am wondering in the context of these high emission lifestyles. So my question, in this context of carbon dioxide, how the high emission lifestyles should be treated as a public health issue? Thank you.
So how should high emissions be addressed as a public health issue? That's another great question. I like you, Gilbert. So it is clearly a health issue as health concerns about extreme heat, and of course, just so many aspects of causing flooding and other extreme weather events. All are things that ultimately end up killing people. So these emissions are very much a health issue. And again, unfortunately, in the current political situation in the U.S., our federal government is trying to pretend that that's not true. I am hoping this is relatively short-lived and that some court cases might strike down the issues related to the endangerment finding, which was what allowed the Environmental Protection Agency here in the U.S. to regulate carbon emissions. That was recently struck down in the last month or two. But it's real. So we need to keep on teaching and learning about that. And we need to figure out how to bring that to public policy. And that's a heavy but incredibly important lift. So I'm not quite sure what else to say about it other than recognizing that yes, this is a health emergency, really. Is that a good enough answer, Gilbert? It's not satisfying to me.
Thank you. Yeah, thank you very much.
Yeah.
Well, we are at the top of the hour, so I just want to first thank you, Don, for the great presentations, and thank everybody for coming and for participating. Again, be sure that that we do have your email address so we can send you follow-up. Don will be giving a larger version of the first part of his talk next week on Tuesday. Actually, for you, it'll be 5 a.m. Is Pakistan time, so you might not. It might be a little hard for you to get up for that, but if you register, that you can still get the recording from that. And then next week, the US is going to be changing our time system. We're moving ahead 1 hour. So whatever time it is for you right now, that will be the time that we are beginning next week. So you'll be able to have one extra hour um, of daylight before you get to this point. And then and at this we don't have a presenter at that time, but what we'll be doing, actually I can tell you what time it is, I think. That well, use a time converter, but we will be in Eastern daylight time, so um, that'll be 7 p.m. Pakistani time, and then um, so that will be just a chance for you to kind of report and talk about what's going on with you, and then next Thursday at 7 p.m. I put this in the chat, 7 p.m. Pakistani time. We'll have a presentation, an interactive presentation called Sustainability Through the Eyes of a Child. And this is a presenter who has worked with a lot of children's programs, and she's an actor and has a program on a local um, TV station, and she has a live rooster that participates with that. So, try to join us next Thursday at 7 p.m. Pakistani time for that, and we'll send the registration information in the follow-up email. So if you have any questions, you can stay on and ask Don for a couple of minutes or talk with me. But otherwise, we'll conclude for today. And again, um, please do make sure that I have your email address so that we can follow up with you. And thank you all for joining us today and for being part of Worldwide Climate and Justice Education Month. And let's have a round of applause for Don, our speaker.
Thank you all. And like David said, I'm happy to stick around for a few more minutes.
I'm going to stop the recording now.
Okey-doke.
Oops.